Hi, this is Kevin Trainer. Welcome to part one of my tutorial on chapter 8 of the third edition Zelle Python programming book. And in these tutorials, there are going to be four. They're going to correspond one for one with the exercises that you've been given for the homework assignment. And there's going to be a lot of parallelism between what I'm doing and what you're going to be doing. So for testing, I have created a common set of files that I distributed as starter files. The first thing that I'm going to do is I'm going to copy those in and put them in my project. There are a bunch of text files that we use to test our code, and I want to make sure that we're using the same test data. Okay, so we're not quite at that one yet, but we'll be there in a couple of minutes. Okay, now the first of the programs we're going to do, the one that we're going to do here in part one, is what I'm going to copy in right now. Okay, and the real exercise version of it is going to be called Sentinel Loop Using Break. And my tutorial version just has the name tutorial at the beginning in order to keep them differentiated from each other. So in this program, we're going to read a series of integers that we're going to have the user type at the console. And this is going to be the classic Sentinel loop that we learned in chapter 8. And as the Sentinel value, we're just going to have the user press enter. And it's going to give us in the program, we're going to read the empty string, and we're going to know then that we've gotten the signal to stop with the data entry process and to report the results. Okay, now the other thing that's going to go on here, in addition to doing the prompting for the series of integers, is we're going to be analyzing the data. Now, in my tutorial version, I'm going to count the number of integers that I get that are less than 0. I'm going to count the number that are 0 and the number that are greater than 0. In the version that you're going to do a slightly different analysis, but the code is fairly parallel. So let's look at the code here, okay? All the code is in the main. And this is still a pretty good size of program to fit into the main. You can really get all the code into the main. You can kind of see it on one page. You can kind of see all of what's going on. None of the code is so detailed so to be distracting. So I don't think we need to refactor it further and to extract functions out of it. I think it's just the right size. Okay. So here's what we're doing. We have a loop that is going to read from the console, which of course we do with input, right? And we're going to get back every time we ask them for input, we're going to get back a string. Okay, and this is the way it's currently designed. It works with a break. So the while is this a classic while true with which would give us an infinite loop if not for the break statement. So provided that we get to break, we're not going to be in it forever. We're going to be in it for some finite length of time. Okay? All right. So what do we do while we're in the loop? Well, first let's look at the initialization that we do. We print out a polite message about what the program's going to do. A lot of times that just does a good job of showing that the program has started in a polite way. Now we've got to count for less than 0, equals 0, greater than 0. And of course we reset all those counts down to 0. And then we get into our main loop, which again would be an endless loop if it were not for the break. So the first thing that we do is that we prompt for and get the input as a string. If the input that we get is the sentinel value, the empty string, well then we break out of the loop. Okay? That means we've done all the processing. Else, we should have a proper int. So we're going to use the function int to convert the string to an int, and then we're going to test it. Okay, and if it's less than 0, we're going to bump up the less than 0 count. Else if it's equal to 0, we're going to bump up the 0 count. Else we're going to assume it's greater than 0, and we're going to bump up the greater than 0 count. So this is going to go on until we reach the sentinel value, in which case we're going to break, and that's going to stop the while loop. And we're going to come down here and we're going to print out the analysis of the input. Now, in our case, okay, it wouldn't be the end of the world that we reported that we got 0 of all of these. And you could imply from that we didn't get any input at all. But I think it's always polite to tell the user when you got empty input. Okay? So we're going to detect that. So we're going to test if we didn't get any input at all, which we're able to detect by the sum of the 3 counts being equal to 0. Then we're just going to print you did not provide any integers to process. Else, well then we know we got integers to process it, and we're going to print out the answers. And we're going to print the number of integers less than 0 is, and then we're going to use that trick that allows us to have a period immediately after the integer that we print. If we just print the string that says the number of integers less than 0 is, and then a comma, and then count less than 0, a comma, and then a period, there's going to be a space between the integer count and the period, which is not really proper English prose. So we've had examples in our text and in some of our tutorial exercises and hand-in exercises where we have converted this integer to a string so that we can concatenate it with a period so that the period is right up against the integer. And we've done that for all 3 of these prints. The first one is the less than 0 count. The second is equal 0 count. The third is the 0 count. Okay, well, so that's the code. It's time to test. Of course, I've already tested it, so this should work. Now, what conditions do I want to test? Okay, I always want you to be able to handle no input. Okay, So the first case I want to test is where the user just presses enter the first time through. So let's give that a test. We're going to run it, and let's make our console a little bigger, and let's just press enter. And we very politely got you did not provide any integers to process. So we detected an immediate end of file, end of input, very gracefully. We finished the program. That looks great. Well, how about if we really do have input? Well, okay, let's do this again. Well, I think we want to make sure that it can find a less than 0, it can find a 0, and it can find a greater than 0. So I'm going to have 2 less than 0, minus 1, minus 1,000. Okay, I'm going to have 3 zeros, 0, 0, 0. And I'm going to have 1 greater than 0, 999. And then let's see what we get back. Oh, we didn't give the sentinel value yet, so let's do that. Okay, so number of integers less than 0, 2. Yeah, that was good. Number of integers equal 0, 3. That's good. Number of integers greater than 0, 1. Well, I think we did that. The one thing that I wanted to test out and make sure it got properly handled was, what if I tried to enter a negative 0? What would I get? And it turns out it handles it pretty well. Let's run it one more time. Okay, let's say we want to enter a negative 0. Okay, and that's all. And it counts it as a 0. Okay, so that's a pretty reasonable way to handle a negative 0. So that's pretty good. Okay, and of course, we're not catching the value error. So if we run it and we type in "Hi Mom," we're going to get a value error, but that's okay. Okay. We learned how to catch that back in Chapter 7, but that's really not what we're concentrating on in this example here. So that's it for Part 1. Again, you're going to be doing a program very similar to this, but the kind of analysis that you're going to be doing and the things that you're going to be counting are going to be similar to, but not the same as, the ones that I did here. So good luck with that, and I'll see you back here for Part 2.